Anyway, now classification of alkaloids. Classification. There are something like 10 types of alkaloids. Okay. Which I will just enumerate them one by one. That's all. And briefly explain to you, give one example each. First one is phenylethylamine alkaloids. Phenylethylamine alkaloids. I think it is this you don't just don't write it. Not required. Okay. So many names are there which is not going to give you any. I don't think that will come for the exam also. Okay, we'll go for the general properties of alkaloids. That is something which will be general properties of alkaloids. General properties of alkaloids. Writing is very difficult. What I will do is I will take another board. That looks to be better. So this board is very. Let me take a Z board. Let me see whether that will work. Just wait a few minutes. Yeah, inside board is there. One second. Yeah. Let me share this board. Yeah, now you should be able to see that. Are you able to see the board? Can you see the board now? കാണുന്നുണ്ടോ board കാണുന്നുണ്ടോ
കാണുന്നുണ്ട് സർ
ഞാൻ വരുന്ന കാണുന്നുണ്ടോ ഉണ്ടല്ലേ ഓക്കെ ശരി now let me okay now so general properties of alkaloids. General properties of alkaloids. The first property, majority of them are crystalline solids. First property, majority are crystalline solids. Oh, it's getting disconnected. That's a problem. Majority is crystalline solid. Only few exceptions are there. The exceptions are two. One is choline and the other is nicotine. Exceptions which are liquids. Choline and other is nicotine. These two are liquids, but others are, or almost all of them are solids. Okay, and all these solids, are insoluble or sparingly soluble in water. In water. Okay, except the quinine, of course, these liquids are soluble in water, but the solids are insoluble or sparingly soluble in water, and they are soluble in organic solvents. Soluble in organic solvents. So that is the second property. Number 3, they are optically active. Optically active. And most of them are lever rotatory. Most are lever rotatory. You know what is lever rotatory. Now the fourth point, they are basic in character. They are basic in character. They are basic in character. That means with acids they will react. They are basics. They will react. They will react with acid to form salts. With acid and form salts. Which is, of course, most of these salts are soluble in water. These salts are soluble in water. Now, next property. Now, these salts, which are formed by the reaction, salts formed with acid will react with certain specific reagent. Will react with certain reagents different reagents for different compounds. This is all investigated and give some characteristic colors and give certain characteristic colors. Characteristic colors. So this you can use to identify a alkaloid. So this can be used as a technique used for identifying an alkaloid. So if different alkaloids are giving different color, of course, from the color you can easily identify them. And in certain cases, they don't form the different color, but they form certain compounds having definite melting point. So that way also you can establish the identity of an alkaloid. Okay. And the most important thing is they almost all of them show characteristic physiological property. That is on the animal body or human body, you can say they have certain properties. They show certain characteristics on the human body. Okay. Now, so they have characteristic properties. Can you see the board now? No? One sec. I think lost the. One sec. Yeah. So they have characteristic physiological properties. What is the meaning of physiological property? It affects your body. Okay. Now see, there are some of them are very good poisons. For example, quinine. Quinine is a poison. You must have heard that story of Socrates. He was fed with hemlock, extract from hemlock. And that was the compound extracted from hemlock is what is called quinine. So he was poisoned to death using this alkaloid. Similarly, there is another one called strychnine. It affects your nervous system. You'll get totally paralyzed in death. Strychnine. You must be knowing the locals. You must be knowing that മീൻകള്ളി കുരു നമ്മുടെ നാട്ടിലൊക്കെ കിട്ടുന്ന ഒരു സാധനം. So if some kids are eating it, it will cause diarrhea. Okay. So similar problems will be there. That is what is called physiological effect. And many of them are used as drugs. I told you. Reserpine. Yesterday I told you about reserpine. It's a very big organic compound which is isolated from what I told you. What is that called? Nitya Kalyani, a plant material. The first heart natural product isolated against the heart diseases. Okay. So these are the different characteristics of properties of alkaloids. Let us look at individual alkaloids. Number one, nicotine. Nicotine. The structure, this is the structure. It's practically simple. I don't know whether you remember this. This is a pyridine ring, pyridine. And this here is a nitrogen with a methyl group, cycloprop, sorry, five, this is a pyrrolidine ring. This is a pyrrolidine ring. And this is a pyridine ring. Okay. So this is, so it has got an ethyl group. So it's a tertiary amine. See, it is basic, I told you. This is a tertiary amine. Okay. This is also an amine with a amino group. This is more basic, you know that. And here is an asymmetric carbon. Asymmetric carbon. So if you have an asymmetric carbon, there will be two isomers which will show optical activity. And this is obtained from tobacco, oveda. You know that. And that causes cancer and all this stuff, you know. Right. So this is and the extraction of nicotine. What we can do is how will you get the nicotine out from tobacco? What is the method of getting nicotine extracted from tobacco? You take the tobacco leaves, are taken, crushed into powder, and extract with cold water. First, cold water extraction. So some water soluble material will come out. And you know, the nicotine is also water soluble. Okay. Now this solution, this aqueous extract is acidified. Acidified. And the and this water solution is extracted with ether. To remove uh, other organic impurities like ether soluble hydrocarbons and all will come. Other compounds will come into the ether layer, and we are going to lose this ether layer can be removed, and into water insoluble material will go into that. Okay, rather water insoluble means which is more soluble in ether. Because see here, what is happening is your tobacco contains nicotine. Nicotine is water soluble. It has come to the water layer. From the water layer, what we are doing is we are adding acid. So nicotine will form the salt of nicotine. Okay. So here it forms a salt. It forms salt. This salt is not at all soluble in ether. This salt is not, so it will never escape this water layer. But when you add ether, some of these compounds will be having some of the other components, which is coming out as a waste, will be having solubility in ether, and that can be removed. Okay. So those organic compounds which have some solubility in ether also can be removed from this. So what remains is only the pure form of or maximum purity form of the alkaloid, which is the major is nicotine. So nicotine is present in the aqueous phase as a salt. So nicotine salt is basified now. Now remember, when you basify, the free base The free nicotine is released, the salt is broken, and free nicotine is released, and this is extracted with it. Remember, the free nicotine is having better solubility in ether. Free nicotine is having better solubility in ether than in water. So keep on extracting this. Remember, this nicotine is also soluble in water. Nicotine is also soluble in water, but what we are doing is we are extracting many times with ether so that the nicotine comes into the ether layer slowly, step by step. So 2 or 3 or 4 extraction has to be done. So free nicotine released is extracted with ether. Okay. And now the ether extract is evaporated. Evaporate the ether to recover the nicotine. Evaporate ether to recover nicotine. If you have enough material, you can purify by distillation. Okay. Now or you can purify this by converting this into oxalate. Okay. So this that is nicotine crude material. Crude means nicotine crude containing some impurity. Now this crude nicotine is taken and you have to purify this. For that purpose, you treat with oxalic acid. Okay. You treat it with oxalic acid. So it forms nicotine oxalate. Nicotine oxalate. The nicotine oxalate is a crystalline solid. It is a crystalline solid. So it's a crystalline solid. So what you can do is you can recrystallize this. So recrystallize this solid. Okay. Recrystallize the solid. And this is the crystals of the oxalate salt. The salt crystals are, are treated with potassium hydroxide to free the nicotine. And the liquid is distilled to get the pure content. It is distilled to get the pure content. Okay? Right. Now, so this is how you can extract nicotine. The physiological activity of nicotine. What are the physiological activities? Physiological activity. They may ask you the short questions for this, short answer, or a small paragraph debating on each one of this. Nicotine is extremely poisonous. In the pure form. And in very small doses, like smoking, in small doses, it will activate your brain, stimulates the brain. In small dose, it stimulate the CNS. CNS means central nervous system. Central nervous system. And that is what the kick you are getting. You know, you get a kick when you have a smoke. When you smoke a cigarette, you get what is called the kick, right? That is because it is affecting your brain. Okay, but it causes a and it will and once that happens, it will increase the heartbeat, increase heartbeat, and also it will constrict the blood vessel. That is, the blood vessel will shrink. Blood vessels will shrink. So what is the consequence of that? Your blood pressure will increase. Okay, the pressure of the blood will be increasing, and if you have still more, some 30 to 50 milligram, if you have, if you conceive something like 30 to 50 milligrams of this, that will cause death. Okay, so this is the problem, and you know it will cause long-term use of this nicotine. Long-term use will cause bronchitis or bronchial asthma. Long-term use will cause bronchial asthma. Right? So these are the problems with this molecule, and also ultimately it may lead to cancer. Mouth cancer, you are very, it is well known that tobacco, chewing of tobacco, and smoking both will cause mouth cancer as well as lung cancer, lung and mouth cancer. Okay, but it has got many uses also. It is in dilute solution. It's a good insecticide. In dilute solution, it is an insecticide. It is a good insecticide. CID. Right. So next compound is quinine. C O sorry CONINE. Quinine is a uh, quinine is the one which I was talking about, the Socrates and what you studied all this. Okay. Now quinine is having a very simple structure, very similar structure. It's a six-membered ring with a nitrogen. Of course, almost all these compounds should contain nitrogen. And here is a compound. Yes, that's it. You have a H here. That's all. This is quinine. And remember, this is a piperidine ring. This is a piperidine. P-I. It's a piperidine ring. So now again the physiological activity, we just have to go to the physiological activity. It causes central nervous system and causes paralysis. Attack, I'll use the word attack, that is better. Attack CNS and cause paralysis. Most of these alkaloids have very bad effect on the human body. The bad effect is being utilized in certain cases for good effect. That's all. Okay. So this is the one which is present in which was given to so-called Greek philosopher Socrates. Okay. Conium. Next compound is piperine. Piperine. Now the word itself gives an indication that it's a natural thing when we cover our common substance known as pepper. Pepper. P-E-P-P-E-R. P-E-P-P-E-R. Right? Pepper. Kurumulagu. So this is alkaloid which is present in pepper. And you can do experiment in the lab. Simple. By taking some pepper and extracting with methanol or hexane, whatever is the solvent, and you can get pure piperine, white solid. Okay. So this is present in pepper. Now you can extract, what you can do is you can take this, the pepper is extracted. Pepper is extracted with ethanol. Extracted with ethanol. And the solvent is evaporated. Okay. And solvent is evaporated. Now this residue is taken. Residue is taken and treated with sodium hydroxide. Okay. To remove some resin. It is washed with sodium hydroxide. Washed. To remove some resins. And what is left behind? The residue is again dissolved in hot water, hot alcohol. Is dissolved in hot alcohol. And cooled to get the crystal. And cooled to get the crystals. Crystalline material. So this is how you, and the structure, this is a little complicated structure. Of course, not that very easy to write, but let me see whether I can.